Good evening and hello and welcome to all our participants today. We are back again on a Thursday bringing you Discover Design, a webinar which is a series of understanding what design does, what is the details of design, and how does it help all of us. We bring this to you from JS Institute of Design. Today our topic is tapping daylight in built environments. We have an expert in Gurneet Singh who's here with us to share a lot of details, but I'm very sure many of us are going to start understanding right from the beginning in simple forms what tapping daylight means in built environment. I'd like to just introduce a bit about Discover Design before that. Discover Design is a series of webinars brought by JS Institute of Design to help us look at the domain of design. And we have done in the past many webinars to discover what is interior design, what are the various spaces where designers have been involved with, what does it take to design an interior space, what are the different elements in it, and how have experts, whether designers, whether technologists, or whether technical experts have looked at enriching the interior spaces for our comfort. We are going to, just to begin, I'm going to just let all our participants know, if you have any questions, please put it in the question and answer box, and we will take up the questions once our presentation is over. Okay, and of course, I need to introduce ourselves. My name is Nain Xiao. I've been heading the academics at GS Institute of Design, I have many years of experience in education and design domain as a practitioner. Let me now introduce Gurneet to you. There are many things I need to be very careful when I speak about him because I do think the specifics in his description really matter. So I'd like you to listen to it very carefully. Gurneet is an experienced sustainability and energy efficiency consultant, building performance diagnostics expert and an integrator, and he's led the energy efficiency team at EDS for 15 years. His experience includes areas such as energy sector policy and regulatory implementations, techno-economic feasibility studies, energy performance contracting projects, LEED, LEED, and GRIHA certification projects. He also specializes in integrated building design, using simulation tools to assist in the design and delivery of energy efficient buildings, in particular in predicting the performance of the daylight systems and energy efficient cooling services. I'm very sure Gurneet is going to help us understand what daylight to us really seems like an everyday thing. And sometimes in the cold winters, warm daylight appears very comforting. And in the summers, of course, it can be too hot to handle. But I'm going to welcome Gurneet to come and explain to us a lot more in technical terms. So welcome, Gurneet. We're happy to have you here today. Please go ahead. If you'd like to add on to some of our introduction to help our participants understand you better, you are most welcome to. And the platform is yours.
Thank you, sir. I think you have covered, you have given an introduction thing. So just basically my interest is in daylight analysis and simulation. So that's why I chose this topic of tapping daylighting in built environment. So let me just share my screen. Okay. Right. Yes. So I hope my screen is visible.
Yes, now it is.
So I welcome you all. Tapping daylight in built environment is very important as it boosts the health and mentality of its occupant. it make our building healthier, and also it is more energy efficient as you save interior lighting energy use because you are getting daylighting. So let us just try to understand why this is important. The simple reason why daylight and sunlight is important is because sun has been there for almost like billion of years, long before life came to existence. It is by far the most important source of energy to the life on Earth. Sunlight is also called life-giving since all the life on planet, whether it's plants, animals, human beings, they are fueled by it. The energy from sun is transferred in the form of electromagnetic radiation. In particular, it consists of infrared spectrum, the visible spectrum, which is the daylight, and the ultraviolet spectrum. Because of the same reason, since sun has been there before we came into existence, our bodies are adapted and developed with daylighting around, right? Our body and many of its functions require sunlight, and scientific research indicates that sunlight eliminates depression, it improves mood, right? Especially for people who are in North India with winter months. If you don't get sun for a day, it feels like a depressed that you are depressed. So it definitely improves mood and it reduces stress, and it also improves sleep quality. Now, if you ask my son, my son was sitting when I was preparing this presentation, so he questioned me, how come sunlight or daylight can help sleep quality? He says that when, he hates sun because he has to wake up in the morning. So let us see how daylight improves sleep quality. So there is this term called circadian rhythm. So our circadian cycle or the biological cycle is triggered with daylighting. Circadian rhythm is a natural internal process that regulates the sleep and the wake cycle, which repeats roughly every 24 hours. So in a simple term, I should say the right amount of exposure to sunlight, and then to nighttime drives this circadian system of our body. Because of the same reason, in earlier times, one of the harshest punishment was to lock the prisoner in a room with no daylight and no views.
Correct.
Over the time, the prisoner generally loses the touch with reality and the sense of time, and eventually becomes disoriented, which impacts his mind and health. A recent study by Northwestern University and the University of Illinois did on office workers. So they did the study where they monitored the sleep time and the daytime activity levels for a group of office workers. So among this group, they divided them into two batches. One batch was exposed to enough daylighting, so their workstation was placed in a way that they get good daylighting, and other was not getting enough daylighting. And what they observed was the group that had exposure to daylighting slept 46 minutes more on an average than their peers. And also they showed more energy and vitality during the day compared to the other batch. So that is the importance of daylighting in our life. So these are some of the pictures of daylit spaces, and I am sure you must be feeling these pictures are so pleasing that you feel that yes, you are connected with nature on that. Hence, it is very important to design a space or a building in such a way to have effective and comfortable daylighting. So you must be thinking that when daylighting has got so many benefits, then how and when can daylighting be uncomfortable? So when I said that, you need to daylight in such a way so that you have effective and comfortable daylighting. So is there times when daylighting can be uncomfortable? So let's just see that. So we all have heard about this term, more the better. Yes, more money is better, but not always. We all know excess of everything is bad. The same applies to the daylight too. We know that more daylight we get in our office, the more we will save on electric energy, right? And we have also seen the benefits of daylighting on human performance, right? But when it comes to daylight, more is not always good, right? Excess of daylight also causes glare and discomfort. So at the same time, so once you have uncontrolled or unwanted daylight coming in order to control that, as an occupant, I will either put on curtains or I will put on blinds, right? So though I'm getting enough daylighting through my windows, but as soon as I put on my blinds, that means I am cutting off the daylight. So I am also losing on the energy savings due to interior lighting, right? These are pictures of some of the buildings. I think most of you are aware which buildings are these. You can actually see the whole building facade is covered by the internal blinds. Right. This is because the direct sun is penetrating in the space and is hitting the workstation. And the people inside the space at their workstation are not able to perform their task because of the glare issue, because the high amount of daylighting or sunlight is creating a contrast, creating a high contrast where they are not able to concentrate on their workstation. Some more pictures of the building. You can actually see, though we are glass. In fact, glass, I really love glass. And I feel that glass has been really instrumental in bringing in daylighting. If you see the buildings around 3 decades or 2 decades ago, they were all concrete buildings with small windows in that. But with the glass, really there are like good daylit building, right? And this is another one. This is for a building in South India. Yeah. So if you see, because of the glass and the architecture and our location as in India, there is a huge potential to harvest daylighting and to harvest the benefit from daylighting, provided it is designed in a proper way. So now let's just have a quick poll, try to understand. I would request the IT team to launch the poll. The question is, how many of you have access to good daylighting without any unwanted glare at your workplace? So just wanted to hear from you. Okay.
So that's a very healthy living. I can see that.
That's good. That's good.
Yes, yes.
Good to see that most of you have access to good daylighting and without any unwanted glare. That's good to hear that. Okay. So now let me just. So now let me take you through some daylight strategies which can help you design effective and comfortable daylighting. The very first strategy as an architect or as a designer or as a client, or even if you are buying a building or if you are leasing out a building as a facility manager, is to see the floor depth of that place, right, of that building. So the very first strategy is to optimize the floor depth so that you have maximum floor area having good daylighting. And what is the thumb rule. The rule says the thumb rule is 2H or 15 feet. The rule says that the daylight penetration from a window on a wall can penetrate up to 2 times the head height of the window from the floor, right? So the lintel level in technical terms, the height, the lintel level from the floor, you multiply it by 2, you get the depth of the floor where you can assume by thumb rule that it will get sufficient daylighting, right? So generally the office space has a 4-meter floor to floor height, and windows are up to like 2.4 meter or 3 meters. So let's say 3 meter. That means sufficient daylight can penetrate up to 2 into 3 meter. That is up to 6 meters, right? Or 15 to 18 feet. So whenever you are designing your floor plate or you are leasing out a space, just see whether you are able to get around 16 meters to 20 meter of office space. So if your office is too deep or office space is too deep, then only certain part of the office will get daylighting. Rest will be partially daylit or maybe under lit, right? The same strategy was applied when we were designing the Punjab National Bank along with the architect Rajinder Kumar and the associate. So this was a competition project, and the whole idea was the client gave the brief that they want an energy efficient, sustainable building design. So what we started the design. Again, it was a site which gave the potential to have a deep floor plate. But what we did was we introduced a courtyard in between and broke the deep floor plate into smaller wings of floor plate. So this helped us in getting daylighting from both the sides to have well daylit space, office space. This is an interior picture from one wing towards the other wing. This is the connection between the two wings at a higher level. And the whole design was done in such a way that it facilitated the cross movement of windows. So this space was all open, and similarly the front was all open so that the wind can also flow through this space, and the occupants of the building get a nice courtyard which is shaded by solar panels. So this courtyard had a frame structure which is solar panels were installed in that, and there were some openings for the skylight so that the daylight can penetrate through this portion, right? So the whole idea was to create a micro environment within the building, which is well shaded, well ventilated, and have got good daylight in that space.
So I have a question here, Gurneet, for you.
Yeah.
Any of the architectural projects which has a very intentional optimization of the sunlight, like such as in this building, does the brief of the building begin with saying that whatever may be the functional usage of the space, that this building has to have certain percentage of sunlight to be inbuilt and available to the users? Is that ever a brief in a project, architectural project?
Not really. There are, like, I would say only few of the client they demand that, but most of them they don't even talk about that. That's why we were also part of development of the energy codes for India. And the latest energy code, the ECBC 2017, and in fact, I believe this is the only code in the world which has energy code in the world which has incorporated daylighting as a mandatory requirement in energy codes. So now with this code, there is a mandate that you need to get certain percentage of your floor plate well daylit, right? So only few corporates they demand that they need to have daylighting, but the rest of the developers and other people, they talk more about efficiency, floor efficiency. They want deep floor plates. So from their end, generally, there's no brief on daylighting.
Right.
So that's the reason, in fact, all the buildings are glass facade and are
Yeah.
covered with all blinds, because the design is not done, because it does not block the unwanted glare.
Right. So just a very quick question again. With such kind of glass facade, which I noticed in the earlier DLF structure that you were showing, they may have found another answer to block so much of sunlight. But how do these buildings or design of such buildings ever get passed in terms of feasibility or safety for the people who are going to use it? I'm not talking about safety in terms of structural safety, but in terms of this, so much of extra sunlight is not really healthy even for people who are using the building. And there is heat entrapment and many of these factors which happen because of such a building.
Yes, yes.
So I'm wondering whether there is anything around such a law.
Yes, you are right on that thing. And I think the reason behind this is the end user is not aware
Okay.
of the benefit. So the end user, the people who are occupying that space, or the HR department of that firm, because these are all core and shell kind of a building, which are leased out to the people, right? So to MNCs, to firms. And the well-being of an employee of that firm is generally taken care by the HR department. So the employees and the HR department, they are not aware of the benefits of having a glare-free daylight, or even good interior lighting design, or air quality, right? So those things has never come as a requirement from the end user, right? So that's
Right.
the reason. So if we are able to create an awareness among the end user, I am sure this will change.
Mm-hmm. Sure.
On the similar fashion, this is the Infosys Hyderabad building. This is the first building where they changed their way of designing a building. Initially, Infosys building were also glass building. So they switched to a sustainable building design. Again, this was designed as an H-shape form. So there were like two H-shape form, and each arm or the wing was the depth of that wing was designed up to like 16 to 20 meters, not more than that. It was restricted to 16 to 20 meters on that, right? The whole idea was to get enough daylighting from both the sides. So this is the south side, and to get it from the other side. Similarly for the other arms. Another important aspect of good daylight design is to achieve a balance of light and heat, right? At certain times of the day, at each orientation, the light will be too bright and may produce a strong glare, right, inside the building, as we have seen in our previous slide. So shading plays a very, very important role in preventing this, and shading plays a very important role in daylight design. So I request everyone to look into this shading part. Shading is nothing but it's a combination of horizontal and vertical elements which vary depending on the geographical location, whether you are located in whether your project is in New Delhi or in Chennai or in Australia. So based on where you are located, the shading elements, the depth, the requirement will vary based on the climate, whether you want to block the heat or you want the sun to come in, and the building orientation, which orientation is your building. If it is north south, it's easy to block the sun because the sun is more or less overhead. So during noon time, the sun is overhead. Only early morning and late evening, the sun is at a low angle. So depending on what is your orientation of the building, these shading elements, the design vary. The shading elements, this strategy basically allow natural light to come in, but it blocks the heat. Again, this is the Infosys building, the facade, the detail of that facade, where they first recessed the window. So it already gave them some shading, and then they added another shade onto that horizontal shade. So this horizontal shade was done to protect the window from the sun around 10 a.m. till 3 p.m. And actually, you can see the shadow on this column, right? So this is shaded, and vertical elements was introduced to block the early morning or the morning sun and the evening sun. Uh, Infosys is one of the client which I was talking about, where they have put this as a design criteria for an architect, that their design, whatever a design architect proposes, should meet. There were three criteria. So first criteria is that they should ensure that there is no direct solar radiation hitting any workstation, right? So the architect has to design the building facade in such a way that there is no direct sun coming inside the building or hitting the workstation. The second one is they also specify that they want at least 100% of their space to be well daylit. And the third one is in terms of heat gain. They say that you need to design your facade or the specs of your facade, glass, and the wall so that the peak ingress heat load from envelope is not above certain threshold. In fact, this is in this project we also went a step ahead. We after detailed simulation and analysis, we also went to the site and checked to see whether the simulation results were in line with or the actual results of the building were in line with simulation. So we actually went to the site, uh, checked what are the sky conditions and the cloud cover, uh, took actual material specifications, and then calibrated our thermal and daylight simulation model with actual materials with the final design and simulated it. So this is a isolux contour level in a floor plan of a of fifth floor, and then we plotted this. So the red part is what we simulated, and the black line is what we measured, and the green part is the outside lux level. So if you see it, the measured and the simulated are very close to each other. I just wanted to share the process because that's the power of simulation, where you can actually predict the performance of your design, and you can evaluate different design options using simulation tools. The next project that I want to discuss is the headquarters for Visage Beauty Products. This is based in Noida. This facade, again, the architect is DCA architect. The objective of by DCA architect was to cut the summer sun completely. They wanted to have a glare-free interior. And so this front facade is southwest facing facade, and the facade on your left side is northwest facing facade. We were able to cut the sun, and along with the visual comfort level, we were also able to achieve the thermal comfort level, right? So since this is a southwest facade, this is exposed to sun after 3 p.m., which is a low angle sun. So that's why you see this as a vertical fin at an angle, right? This is another view of the angle. The other benefit of shading is that besides radiant and glare control, it also helps in reduction of your cooling load, right? As the solar gain inside the building is now zero. So over here, there was zero solar gains. If we haven't done shading, then there would have been there would have been some solar gains coming into the building, contributing to the cooling load. Right? And generally, in my experience, we have observed that many of the clients or the architect, there is a misconception that, if you go with a vertical shading, then you are actually blocking an internal view. The occupants will not have view to the outside, right? So let me just show you few pictures from the interior side of the same building. Yes, there are inclined fins So if you look perpendicularly outside, yes, there is no view, but actually you never look outside at 90 degree, right? So you can actually see we are getting good view to the outside, right? Similarly on this side, and you see there is very less of sun coming in these
Correct.
spaces, right? So that's the beauty of the shading devices. And the best part was that when these were being implemented on the site, the construction workers, they preferred working on this floor where the shading was implemented, because they said that it was cooler than the other floors.
Right.
Right. So that was great. That was in fact very interesting.
So while you're at it in talking about shading, daylight and shading, could I ask you to perhaps share with us any information about what kind of material could go on the windows if we don't want to do such a shading like what you're showing here, but you'd like to just bring about some changes through the material usage? Would you be able to help us understand whether there are any
so
materials which could help
yeah,
in that?
fabric could be, there are high performance glass available, but again, you can't achieve zero solar gains with that, right? So it's something like you are putting sunglasses, right? Goggles.
Right.
Even if you put that, you can't see the sun continuously, right? After a
Correct.
certain time, you will still feel discomfort. So yes, sunglasses or a high performance glass will reduce that impact. But once you're getting direct sun coming in or hitting your computer screen, it will create a discomfort, right? And you will put on blinds. So shading, external shading can be anything. We saw in the Infosys building, so they use frosted glass, right? Those are like light colored. Over here, they use cotton steel because they wanted to give a rusty kind of a feeling on that facade, right? It can be a fabric. Architect A.B. Lal has used fabric in this uh, building in Gurgaon. And the next building that I'm just will show is the Suzlon. So they have used small vertical, horizontal louvers as a shading devices, right?
Mhm.
So this is the Suzlon project, which is a global headquarters of Suzlon at Pune. It is around 0.8 million square feet. It was the first building in India which got both Griha 5-star and the LEED Platinum rating. Uh, Again, they have done orientation was done in such a way that you have north and south facing openings, and east and the west facing facades were covered with this louvers, horizontal louvers, right? So you can see in this image. So they don't block the view, but they
Correct.
cut the low angle sun, right? So any sun above 23 degree was blocked with this. So this is again a kind of a thing where you are not doing heavy shading, but these are kind of a perforated shade. And this is again an internal view of Suzlon building. I can see very well daylight. These are the office spaces, and you can actually see the louvers over here. The other things that Suzlon has done is they have really gone into efficient interior lighting. The lighting power density was something lower than zero point 0.7 watts per square feet. They also coupled the day lighting with the interior lighting through sensors. So they connected it with occupancy and the daylight sensors. On the air conditioning side, also because since it's located in Pune, direct and indirect evaporative cooling works well. They were also pre-cooling and doing heat recovery from various equipments. Uh, Being Suzlon, they have on-site renewable energy systems. They have got around 17 windmills on their campus and around 234 solar panels, which contributes to around 6% of their energy used at site. So that brings us to the poll number 2, which
Right.
is
So let's have a the poll.
So the poll is daylighting inside a building when done in a smart way brings physiological prosperity to the users, reduces energy cost, or both.
So what do you think, Gurneet?
So I think I was able to communicate to all of them. Yes.
I think our participants are very smart. But honestly, I want to ask from your experience, do you think
Hello. Mm, I'm not able to hear you. Is it at my end or? So Dakshita, am I audible?
Yes, sir. So you can continue, sir. And Nian ma'am will just be joining back.
Okay, sure. Yes. So, okay. So the next daylight strategy is light shelves. Light shelf is nothing. It is basically a horizontal shelf. It can be termed as internal shading, or external shade can also be used as light shelf. It is generally placed above uh, view window, above the window, to reduce the glare and also to redirect light deeper into the space. So this panel, which is also acting as an external shade, is kind of a light shelf. The upper part of this panel is also reflective. So this panel shades the lower window, and also the sun is reflected deep into the space.
okay.
Yeah. And this is again an internal view of, so this is a factory. This is a garment factory. And I will show you a image of their old shed. So you can actually see what a good ambience created by glare-free daylighting. This was on your left side is the existing factory, and now this is the completed factory image. You can see the difference, and this also impact, as we have discussed, occupant comfort and enhance their productivity. So that's very important for a factory where you should give a nice environment to your occupants.
Mm-hmm.
Similarly, the Infosys, so they have this light shelf. Again, the whole purpose was that the light reflects on this and get uh, reflected deep into the space. Another concept with light shelf is that you can break your building skin or building facade into two parts. You can have this lower part, which is the view window, which is used to view outside, and the upper part is the daylight window. So the view window can have an high performance glass because the occupant is sitting over here, and the daylight window can have a glass which allows more of light to come in, right? So the same facade, you can have two different windows to harness more daylight into the office space. Then clear story and skylights is another strategy. So generally, all the typical warehouse and storage are done like this. So they have shed-like structure with small skylights in between. This is what we did for Organic India warehouse, where we brought in clear story and the skylights. So this is not facing sawtooth skylight. right? And you can actually, I'll show you. So this is something without any skylight, and this is the building with. This is the same warehouse of organic. You can see actually, how well lit is this space, and you can actually see on this wall. Similarly, the same with uh, with a north skylight, how you get the daylight into space. Now let's just move to some advanced daylight systems. So all of these which we covered can be done by the design, and you can term them as a passive system, but there are also advanced daylight systems available. I think you must have come across that. The first one is the solar tubes. Solar tubes is basically channels which take sunlight at the top and transport them through a narrow opening to the space that you want. So these pipes are very reflective from the inside. So once sunlight enters into this, it gets reflected and it transports to the space where you want. Right. So this is one advanced technology. The other one that is now picking up is the electrochromic glass, the glass that tints itself depending on the sun orientation or the amount of radiation falling on that glass. So this works well if you have a west or east facing facade, because generally if you have east or west facing facade, that facade will get sun only for half a day. Rest half part of the day, it will be in shade. So if I have east facing facade, that facade will only get sun during the morning, maybe from 8 till 11:30 or 12. And from 12 onwards, that facade will be in shade. Similarly, the west will receive sun after 3 or 2, but before that, it will be in shade. So there is no point designing a shade, static shade, for those facades, because you are designing it for the worst condition to block the sun, but the time when there is no sun, you are actually blocking diffuse light. So on those facades, either you propose a dynamic shade which moves depending on the sun, or you can go with electrochromic glass. So these strategies work best on east and the west facades. Then there are these small uh, aluminum panel or section which are designed to actually have light penetrate deep into the space, and these can work as a retrofit. So you can actually install these set on the top of your window from inside, and you will actually see that the light is being is reflected and is reflected deep into the space. Right. So this is a very interesting daylight harvesting strategy. That brings us to the poll number 3 before we end the session. So request the team to launch the poll.
Okay, please go ahead, Gurneet.
No, please, you can go ahead.
Okay, let me just read it out. Vernacular architecture can be classified as green building when building and space design relates to vernacular culture, or design provides majority space for daylight and external views, allowing inhabitants to enjoy the seasons and the weather, and colored with various shades of green. So think through which vernacular architecture can be termed as green, having these 3 characteristics. Which one would it be?
Yeah.
All right.
I'm so glad that nobody selected the third option, because I had tough time convincing my family that it's green is not only using green color.
Absolutely. I guess No, we have very informed participants, and of course, the third option just seemed like a put on from our end. But I wanted to check with you if you could help us understand whether in our vernacular architecture, did they actually evolve any methods to control sunlight, daylight, getting into the house, or enmassing daylight for the house?
Yes, yes. In fact, the vernacular architecture, they are they I would say that they are like term called climate responsive design, right?
Mm.
They were, in fact, you see old habitat, all, whether it's Dubai or another thing, those were all designed keeping in mind the climate, right? So hot and dry area had small windows where there were like hot and humid areas. They had got huge windows with cross ventilation, right? So, and in fact, if you see, I was very surprised to read about this SP41. They define the shading requirements very well. And in fact, you see all of the old CPWD or the government buildings, those, all the buildings are all well shaded.
Mhm.
I don't know about the people, there are people around Delhi. If you go to that Patel Chowk metro station, so that Patel circle,
Mhm.
all the buildings around that uh, circle, they have got different shading depending on their orientation, right? So it's only the new buildings where we have actually forgotten about the principles of daylighting and those things, because glass was an easy material. But if you see all the vernacular architecture, I would say they would all achieve the top level of rating in the present green building systems.
All right. So, well, that's some more information for us today. Uh,
Yes.
Sorry, go ahead, Gurneet. We have
Yeah.
something.
So no, just to end the session, I would just like to say daylighting is not just a window thing. It is. It basically requires an integrated design approach. You need to work on the whole building. You need to work with the climate factors. You need to work with building orientation, how the floor plan is laid out, and the interior lighting design elements and the controls. So don't, whenever you are starting a design, I mean, just keep in mind all these factors and then design your building so that you have well daylit office space or well daylit building space.
True.
That brings to me to the end of this my presentation.
Thank you very much. All I can say is that today what we have got is just a small peek into a huge area of how daylight or energy efficiency can be obtained in a building, not only the building structure, but interiors as well, and many aspects attached to that. There are many questions for you, Gurneet. I'm going to put it to you one by one. But meantime, I do think today I've learned a lot. I'm going to just try to figure out some of the things you've talked about. But if you'd like to have a glass of water before you start,
No, I'm okay.
all right. So a question from Nandana. Um, so her question is, don't people move away from sunlight in a building by closing the windows and putting down the blinds because of the sunlight? So how can we balance both the needs?
Yeah, so it's basically not the sunlight, it's basically unwanted sunlight, right?
Correct.
So you can, as I've said, that the best way is to design your building properly and have some kind of sun control, external sun control, that is shading elements. With that, you can actually balance this both the needs. Because of the same reason, Infosys has now, and many corporates are now adopting a no blind policy in their office space, that they would like to have their building designed so that they need not to install blinds in their office space.
Right. Um, In fact, I had a question. I don't know I sort of was taken off the site for a while. I don't know if you heard my question about, are people, even at this present time, more concerned about saving finances by being energy efficient rather than actually being concerned about the health of the humans using that space, whether enough daylight is being is being allowed in that space, or is there over the top daylight being in the allowed in that space?
See, as I said that if you're talking about daylighting, right now, people are not aware of that. I mean,
Correct.
they so the design is not daylight oriented. It is more of floor space efficiency, right?
Right.
So that's the issue.
So we can wait for a long time yet, or are people getting more aware?
People are getting more aware, and now with this codes and green building rating system also putting there is a push from all these parts. So hopefully people will get aware about the benefit of this. And with these kind of situations of COVID and other thing, definitely now the focus has shifted to the occupant health also, and the daylight, besides the indoor air quality, daylight is also an important aspect. So hoping to see a change in that aspect.
Well, this is our first step towards trying to understand this better. But we, as a school, I think GSID would be very keen to continue understanding this particular subject area in depth so that we can share the same passion for it, or rather, knowledge about this with our students. A question from Vandana. What is your take on green building history? I think there's a long question. So, do you want to answer this? Or I'll go on and add more. Do you think that India was the initiator of such codes, as we see many architectural marvels in India on lines of Vastu Shastra?
Mhm.
Or should we believe that we have studied from some foreign council's policy and that is why we follow it?
Uh, See, I would say if you're talking about green building, so when you're talking about green building, I believe Vanna is talking about the green building certification system. But if you see all over the world, almost like uh, 3 decades ago, all the buildings, anywhere in the building, they were all climate responsive, right? Whether it was a building in Dubai or it's a building in New York, they were all responding to the climate. It's only within this 2 decades that uh, the building which is designed in for New York, the same building is now coming up in Dubai. The same building is, so if you see the if nobody tells me where I am, for me Gurgaon, Singapore, Dubai, I could see New York, I could see that as the same building profile, right? All tall buildings with the glass, with the
Correct.
Luco panel and all those things.
Correct.
So it's just because of the demand for to go high rise and to make a statement that the clients are demanding a building which is which looks futuristic, and for them it's glass, high rise, Luco panels. Those gives a feeling of future, that the building is futuristic or there is a iconic building kind of a status, right? But so it's only in this past 2 decades that we have shifted from, I would say, sustainable green buildings architecture to more of a uh, uh, futuristic kind of a building thing. In terms of green building certification, yes, we are kind of a follower to that, because the green building system certification came first in Western countries, and then we adopted that. So that's my answer. I hope
Right.
it clears your.
Right. So thank you for that. Nanda Kumar has a question on, will heat radiation pass through shading devices?
No, so if it is an opaque thing, it will not pass through. But if it is like translucent, less some radiation will pass through that shading device.
All right.
Again, how you are joining the shading device to your structure, because your shading device will get heated up, and then if you are joining it to a structure, then some heat will be passed on to your structure. But radiation, no.
Mhm. All right. And well, a question from Alna. Hello, Alna, a friend of mine. Are there any incentives given by the government to encourage daylight savings? Does building material affect heat? I think
Plus
that.
building material.
So does building material affect heat? HEAT, heat.
Okay. Yes, building material do affect heat. Depending on what kind of material you are using, it will. So each material has this, as you know, heat flows from higher temperature to lower temperature. So that's the conductivity. So each material has this property of called conductivity. Depending on that, the amount of heat is transferred to from higher to lower temperature.
Correct. And she wanted to know whether incentives given by the government.
Right? No, no, I am not aware of any of the incentives.
Do you think people like you could make a difference if you sort of, are you are propagating what is the benefits of such thing, or what should be
Yes.
the expertise level of expertise required? Can't we do better than this?
No, we can definitely do better than this, much better than this. We have seen the buildings in that cyber city thing. So there is a lot of potential, and we have taken the first step of incorporating that in the ECBC code. So let's see how it goes. But yes, there is a need to bring in daylighting. I would say glare-free daylighting into the space.
Okay, another question by Alok. For existing structures, any flats or villas, how do you improve natural light since structural changes are not allowed? Are there any reflectors, etc., available?
Yes, reflectors are available, but if you're saying that it's a flat or a villa, if it is a villa, then it's easy. You just need to maybe change your windows or add more windows into that depending on the design. In the flat, yes, it's difficult. There are reflectors available. In fact, my flat is also north facing, and so I don't get sunlight. But during winters, because my neighbor has installed a reflective glass, so I get the reflected radiation for almost like 1 or 2 hours. So yes, there are reflectors available. If your flat is not getting direct sun or light, you can use those reflectors to uh, have daylighting. In fact, the light shelf is a reflector only. The thing that we discuss, it's a reflector only, which reflects the light deep inside space. And the solar tubes also is a reflective material.
Right. Uh, there's another question. More and more non-technical people have become a part of building design. Is it the reason India doesn't have many good sustainable buildings? This is by Madhan. Oh, is that true? I'm not sure. Is it?
No, it's not the. It's not because non-architects are practicing architecture, but even architects, they have shifted their focus from good design to, uh, and again, it's not their fault. It's basically the demand from the client, right?
Mhm.
If the client wants a building equivalent to something in Dubai, as an architect you need to develop that. And again, now with the new technology coming up, the materials availability, we are moving towards a sustainable building design. And so there is I can see there is a shift. And many corporates like Infosys and other Wipro, they are now making this as a mandate. So when they give this brief to the architect, there is a mandate that they want a sustainable building design. So there is a shift, and people are also now seeing the benefit of having a sustainable building design, right? So definitely there is a shift.
Right. I hope, Madan, you would I hope you would feel a little bit more optimistic, because there are many reasons besides the one you mentioned. And let us be hopeful that we all have more awareness and hence better choices, and we make our decisions accordingly. Another question would be, when using view windows and daylight windows, how can we mitigate the heat gain acquired in the interiors through daylight windows?
Yes. So there are glass available which have higher visible light transmission and lower solar heat gain coefficient. So those kind of glass can be used on the daylight windows. So again, we have to see the balance between daylighting and the thermal ingress part. So depending on the glass, and sometimes you also add some shading on top of your daylight window to obstruct certain part of the solar gain.
Right. Okay. And Gurneet, thank you so much. I think today has been a lot of information, a lot of logical and sensible information. And I do think many of us are going back with some new information and excitement towards what future holds for all of us. But before we I'd like to announce that we do have a poll question for you from GS Institute of Design. We'd like to know whether you guys would be interested to apply, because our admissions are on for the next term starting in January. And please go ahead and answer, put on your choice for the poll. Meanwhile, if anyone of you has more questions regarding this subject domain, Gurneet has very kindly agreed to do any more answering if it requires more clarification. But after this, I do think all of us really, as interior designers, architects, builders, need to pay attention to this particular aspect of energy, which is so abundant in nature. And especially in India, we are blessed with a lot of it. I don't know, there's been no question on energy encashment, or did you talk about really being able to trap this energy for some other use? Is it possible, all this daylight that we have besides solar panels?
Right now, it's the solar panel only by which you can trap this energy. You can transport daylight through solar tubes and other method. But as such, daylight itself, I am not aware that you can store it or maybe reuse it during night. You can only do it through solar panels.
Okay, I'm sure there's a lot more development happening in this particular field. I guess if not as experts, even as consumers, if we are aware of such aspects, we'll make better choices when we go around to buying our own space or using a space. And that ultimately would be an ideal society where people benefit from their surroundings and benefit from the technology that is around us. So thank you all. And we are going to see you again on our webinar, which will be a Thursday. We will announce it earlier. Thank you, Gurneet. Thank you very much for all your time and your efforts.
Thank you for inviting me to conduct this session. Pleasure.
Thank you.
Thank you.
Bye-bye.
Bye.